Okay, so I'm trying not to be too offended because I taught you this, and so you not remembering makes me a little sad. But the first thing is, let's just think about what's going on. So a comic book is worth $5 today, and its value will grow at a rate of 10% per year. Find the model to represent this. Okay, so what do we know? We know right now it costs $5, so let's just pretend it's $5 at year 0, and it's increasing. So even if you don't know the shape, you should know it's definitely going up. So thinking about a logical answer, right now I was writing a model, but if we were predicting, we know the value needs to increase. Now, you might have forgotten, but this is an exponential function. And the first thing we can do is write down the formula for every exponential function. So that's y equals ab to the x. And that's an exponent x. If you're not writing this down, you should be, because I'm just dropping knowledge. Now, a, if you have forgotten, is your initial. It's how much you start with, or how much it costs in the beginning. You probably already know what that one is. B, this is the fun one. This is your factor. It's how much you're multiplying by. This makes sense. If we know it starts at some value and it's changing, we're going to multiply it by something. And then our x is telling us, well, we're not just doing it once, we're doing it over and over and over again. So how many times do we need to do it? So it all makes sense. Now, to find the factor, that's where things get a little juicy. We have two equations to find the factor, depending on if we're increasing or decreasing. Think to yourself, is it increasing or decreasing here? Right, it's increasing. Hopefully that's what you said, because it says it'll grow at a rate of 10%. We don't want to multiply just by 10% because, well, 5 times 10% would actually give us a smaller number. It would only give us 50 cents, and that's not what we want. We know it needs to increase. So what we can do is we can use the formula 1 plus r, or 1 plus the rate, will give us our factor. If we were decreasing, we're not doing it in this problem, but I don't want to just give you misinformation. We would use the form 1 minus r, because we'd want something less than 1 because it's decreasing. So now let's find b. Let me write up here. b equals 1 plus r. So b equals 1 plus. We're not going to put in 10 because we want a rate. And right now we have a percentage. Changing it to a rate will be 0.1. And if you forgot how to do that, whenever we have a percentage, we divide by 100. So 10 divided by 100 is 0.1. So our final b value will be 1.1. Boom. We're done, right? Hopefully you just screamed, no, Mr. Ezaki, we're not done. That was barely one part, because you're right. So I'm going to do a little racing. Wow, fun. Fun. Okay. So we now know what our b value is. Let's substitute that in. Y equals, I'm going to leave a blank right now because we're going to get there next. Something 1 times 1.1 to the x power. And what is that something? Say it with me. Initial. That was too much. Sorry, I apologize. And the initial we know is $5. So we're just going to put $5. Let's make sure we answered the question, write the model or equation that represents the situation. Boom. We've got it. But don't you worry, friends. I have the next problem. Okay, so here's the second part. So y equals 5 times 1.1 to the x power. And we want to find the comic after 17 years. Okay, does it just me or did my pen change? Oh yeah, it did. Oh, okay. I kind of like it though. 17 years. Now we need to think about, is this our input or our output? Is this our independent or our dependent? Well, 17 years, as every year changes, I know my value is going to change. So year is my independent variable. It affects my dependent variable. So I know I'm going to just substitute it in for x. So y equals 5 times 1.1 to the 17th power. And then, okay. You can plug that in. Oh my gosh. You can plug that in and solve. You're welcome. Okay, I have to do one more because this is the real juicy one. So how long until the comic book is worth $50? So we have y equals 5 times 1.1 to the x power. And let's remember, 5 is how much it started with. We know 1.1 is how much it's increasing every year. And then the x is how many times we're multiplying it by, or how many years. You probably can already figure out this 50 we're going to use for, but this is my favorite one because this is actually something that'd be interesting. If you're like a comic book collector, you might want to know like how long until this is actually worth selling, or you're going to want to predict something. So I think this is actually really useful to be like, okay, so I want to make this much money, and then you can go backwards from it. So what we're doing is we know the value is $50. So instead of plugging in for x, which told us, hey, how much is after this many years, this is how much it'll be, we know how much we want it to be, and we're trying to find the years. So we plug in for 50, 5, 1.1 to the x power. Now this one is interesting because we have an exponent, and so solving will not just be as easy as it might be otherwise. Remember, circle the variable we want, and we want to get rid of the thing furthest away using inverse operations. Gosh, I'm having flashbacks to 9th grade. We want to get rid of the further thing. So instead of our boo, 1.1, that's closer, we get rid of our best friend, which is further away. The operation here is multiplication. So the inverse is division. 5 divided by 5 simplifies to 1, but to maintain equality, we need to do it on both sides. 50 divided by 5 gives us 10, and that equals 1.1 to the x power. Now, I don't know if the problem was actually this hard or if I just made it this hard, but next you would actually want to use logarithms to solve this, but I don't think in this class you're probably doing that, so I'm going to leave it there. If you do need to use logarithms, let me know, and I'll gladly dive into that because you know I love my math. But anyway, have a good night. Stay safe, and I hope you're doing well. And if you see anyone else from East End, tell them I miss them, and I hope they're staying safe too. Okay, bye.